Assalamu alaikum student. Today we discuss the topic that is the stationary waves or standing wave. First we discuss the condition that is required for produce the stationary waves or standing waves. First condition that is the should two stationary waves should be in the same frequency. Second point is amplitude must be equal. Wavelength of two waves should be same. Fourth, should travel in opposite direction. Fifth is consist of nodes and anti-nodes. Sixth is constant of discrete number of frequency called harmonics. Now we discuss the shape of the stationary wave, how the stationary wave are produced. When the incident wave is fall on the boundary, then when the wave is reflected from the boundary, the two waves are superimposed and make the stationary or standing wave. Here the incident and reflected wave are superimposed. When the incident wave is reflected back from the medium, they have the same phase in that the incident wave. So here we write these incident and reflected waves on the string will superimpose with each other and form a standing waves. Nodes are points on the string that are rest all the time and have zero amplitude. Antinodes points on the string that have maximum amplitude is called antinode. In the wave, the nodes with where the displacement is zero and antinode with the wave displacement is maximum is known as the antinodes. That is all about the stationary waves. Assalamu alaikum. Now we discuss the method to calculate the wavelength on the stationary wave, how we calculate the distance between the stationary wave or wavelength on the stationary wave. We know that the where the displacement on the wave is zero, that point is called node, and where the displacement is maximum, that point is known as antinode. Here N shows the nodes and A shows the antinode. So A here shows the antinodes or N shows the nodes. Here we show the distance between alternate nodes and antinode. Distance between alternate nodes and antinodes is the lambda. Here the distance between consecutive node and antinode. Distance between the consecutive nodes and antinode is lambda by 2. Here the distance between consecutive antinode is lambda by 2. Then we calculate the distance between nodes and antinodes. This is the nodes and this is the antinode. Distance between them is the lambda by 4. Distance between nodes and antinode is lambda by 4. Assalamu alaikum student. Today we discuss the topic that is the difference between the fundamental harmonic and overtone frequency. But first topic is the fundamental frequency. The lowest possible frequency, the lowest frequency produced by vibration of a string this frequency is called fundamental frequency. This frequency also called first harmonic. What are harmonic? Harmonic are simply integral multiple of the fundamental frequency of a vibrating object. The lowest frequency is called first harmonic. The second harmonic is 2F and third harmonic is 3F and so on. What is overtone? The higher allowed frequency of vibration above the fundamental frequency is called our tone. Assalamu alaikum student. Today we discuss the topic that is the fundamental frequency or first harmonic of a standing wave on a string. We know that the nodes and antinode on a standing wave, that where the amplitude is 0, that point is called node, and where the amplitude is maximum, this point is called antinode. So we know that the distance between two nodes and two antinodes is lambda by 2. So here the distance between the nodes and antinode is lambda by 2. So we write the length of the string, that is equal to lambda by 2. Now we calculate the fundamental frequency or first harmonic. So we know the formula, that is velocity is equal to F into frequency into wavelength. So here we find the fundamental frequency, that is denoted by F1. F1 is equal to V over lambda. Here we calculate the lambda, that is equal to 2L. Put it here. F1 is equal to V over 2L. This frequency on a standing wave is called fundamental frequency or first harmonic on a standing wave. Now we calculate the second harmonic of first overtone on a standing wave. Here we see that here the three nodes and two antinode, we calculate the distance between the wave. We know that the distance between two nodes and to antinode is lambda by 2. So here the distance, this is the node on the standing wave where the amplitude is 0. So distance between the two nodes is lambda by 2. Here is also two nodes. So distance between two nodes is lambda by 2. So here we write L is equal to lambda by 2 plus lambda by 2. So we can write 2 lambda plus lambda. L is equal to 2 lambda over 2. So finally we get L is equal to lambda. We know that the velocity of a wave is equal to frequency into wavelength. Here we calculate the frequency, so we can write f is equal to v over lambda. We find the second harmonic, so f2, and first our tone. Here lambda is equal to L, so f2 is equal to v over L. This frequency is called second harmonic and first overtone on a standing wave. Here we calculate the third harmonic or second overtone on a standing wave. We know that the way the display, where the amplitude of the wave is 0, is point is called node, and where amplitude is maximum, which point is called antinode. Here we know that the distance between two nodes and two antinodes is lambda by 2. So here the distance between the two nodes is lambda by 2. This distance is also lambda by 2, and this distance is also lambda by 2. So total distance is equal to 3 times lambda by 2. So we add those, finally we get 3 lambda over 2. We know that the frequency is equal to v over lambda. Here we calculate the third harmonic, so is equal to f3 is equal to v over lambda. Here we calculate the value of the lambda is equal to 2L over 3. Put it here. So we get 3v over 2L. This is the third harmonic or second overtone on a standing wave. Assalamualaikum student. Today we discuss the wavelength and frequency of nth harmonic on a string. We know that when one loop is produced on a string, then is represented by first harmonic, that is n is equal to 1. When the two loops is produced on a string, then the is shown by the second harmonic, that n is equal to 2. When the three loops is produced on a string, then n is equal to 3, that is the third harmonic. For n is equal to 1, the value of the lambda 1 is equal to 2L, lambda 2 is equal to L, and lambda 3 is equal to 2 by 3L. We discussed it in detail in before lecture. Now we discuss the frequency that we calculate for loop, that is n is equal to 1. So frequency is f1 is equal to v over 2L, f2 is equal to 2v over 2L, and f3 for n is equal to 3 loop is 3v over 2N. Now we write the nth formula for wavelength. Nth wavelength for nth harmonic is, we can write this sequence like that: lambda n is equal to 2L over n. N is equal to 1, 2, 3. When we put n is equal to 1, then lambda 1 is equal to 2L. When 2 is equal to L, when we put 3, that is equal to by 3L. Similarly, we write the formula for frequency for nth harmonic is Fn is equal to Nv over 2L. Here n is equal to 1, 2, and 3 up to so on. So when we put n is equal to 1, then it is equal to v over 2L. When we put 2, then it is equal to v over 2L. When we put 3, then it is equal to 3v over 2. So general formula for wavelength for nth harmonic and frequency for nth harmonic.